Hello, scholars. Welcome to another interesting topic, revolution of the Earth. In our last lesson, we looked at the rotation of the Earth, but this time we'll be looking at the revolution of the Earth. The rotation of the Earth is different from the revolution of the Earth. The Earth moves around the Sun in a fixed elliptical path, and that path is known as its orbit. And when the Earth rotates around its own axis, that is known as rotation. And we looked at the effects. The Earth moves on its orbit at a speed of 30 kilometers per second. And you know that we looked at the speed of the Earth on its own axis at 17,000 kilometers per hour. That gave us a total speed of 24 hours rotating on its own axis. All planets move around the Sun in fixed orbits. Each planet have their own different orbits, so they don't bump into each other. You can see from this video the way each planets move. No matter how they move, they all have their time. They never collide with each other because of the difference in their movement. Some take days, some take years to complete their orbits. I can tell you that the Earth is the only one that has a shorter orbit compared to most other planets. The Earth moving around the Sun is called a revolution. It's different from a rotation. We saw what a rotation was in our former video, and now we'll be looking at the revolution this time. And we would also know that we should take note that on its own axis, when it moves, is known as rotation. As it spins on its own axis. But when it rotates around the Sun, it's called a revolution. Look at the video very well. You can see a rotation on its own axis inclined, and you can see a revolution when the Earth moves around the Sun in an elliptical orbit. That is what the orbit is called, an elliptical orbit. It actually takes the Earth 365 days, 6 hours and 8 minutes, approximately 365 1/4 days to complete one revolution around the Sun. That is why a year has 365 days, because we cannot add a quarter, 6 hours and 8 minutes in the counting of the rotation. So what they do is they add the quarter of the 365 days, that's 6 hours and 8 minutes together, and when you add it together 4 times, you get one extra day, making it 366 days, and that is what we call a leap year. So when you complete 4 years, you celebrate a leap year every 4 years. Though the Earth takes 365 1/4 days to complete one revolution around the Sun, we only take 365 days as 1 year, like I said earlier, because we cannot have 1/4, and that 1/4 is an extra 6 hours 8 minutes. And in class we talked about Pluto not being able to complete its orbit because of the timing. Pluto had an orbit of 267 years from what research told us, and nobody was able to check it, so it was discarded as a planet, and it could only be seen by powerful telescopes, so it was known as a dwarf planet. All right, so to which month we had this extra year, this extra day? To which month do we add it? We just chose that, okay, fine, it comes every 4 years, right? 1/4, 1/4, 1/4, 1/4 into 4 places, we get one extra day, making that year a leap year of 366 days, and it is actually added to February. February is 28 days. When you add a leap year to it, it becomes 29 days. All right, the Earth's axis is always inclined in the same direction at an angle of 23.5. That's 23.5 to the vertical. The inclination of the X-axis together with the Earth's revolution around the Sun causes seasons. We have different seasons. We have autumn, we have springs, we have winter, and we have summer. So the inclination of the Earth on its axis and with the revolution around the Sun causes these different seasons. You can see in the northern hemisphere we have winter, and the southern hemisphere we have summer. On the 22nd of December, you can see that we always experience winter, because the sun is not facing the northern hemisphere. See, the northern hemisphere is dark, while the southern hemisphere is looking a bit lighter, facing the sun. All right, and now we can see that the earth axis, I told you before, is inclined at an angle of 66.5 degrees. But when it moves, when it revolves, it's inclined on its own by 23.5 degrees, and that causes the different seasons from 21st of June throughout the season, and the way the sun faces the earth. Sometimes it's under the earth, sometimes it's on top. It causes the different seasons. What divides the earth into two halves? The equator divides the earth into two halves, and the two halves are called the northern and the southern hemisphere. Please, students, I want you to know that the equator, there's something called an equator. That's what divides the earth into two halves, and we have just the southern and northern hemisphere. The southern hemisphere is below, while the northern hemisphere is on top, above, and you can see the equator at the middle. That line, it divides the earth into two halves. So when it's in position, the northern hemisphere is hotter and experiences summer, while the southern hemisphere experiences winter. You can see the effect of the sun rays on the earth right now. You can see that the northern hemisphere is facing the sun, while the southern hemisphere is away from the sun. That part away from the sun experiences winter, while the part facing the sun experiences summer. During June, you can see it's in summer, but when it moves around throughout the months, let's take that to be position A, and when it gets to position B, I want you to pay attention and see that the part away from the sun, that's the northern hemisphere in position B, is experiencing winter, while the southern hemisphere in position B is experiencing summer. And position B is December. You know, I told you in class, when you watch Home Alone, you discover that it was set on an holiday setting, and it was a snowy movie, which means that they were in December and they were experiencing winter. Please have it in mind that not all country experiences snowfall. We'll be discussing that as we move deeper, but in the States and some parts of Europe, or majorly parts of Europe, and many countries experience winter, and they have snowfall. So now we'll be looking at the meaning of equi and nox, which is equinox. You know, sometimes you choose to say we have a longer day and a shorter night, or a shorter night and a longer day. Anyways, equi means equal and nox means night. Equinox is the time where all places on earth have the same duration of day and night. You can also say equal day and equal night. When you sleep, you enjoy your night, you wake up, it's equal, some are longer. But on 21st of March, the spring equinox, the sun shines directly on the equator. You can see that the equinox is there because the sun is shining directly on the equator. Like we said earlier, the equator is that line that divides the earth into two halves. So you can see that on the 21st of March, we had equal day and equal night in all parts of the earth. While on 23rd of September, the autumn equinox, the sun shines on the northern hemisphere, also giving what? Equal day and equal night. Sol means the sun, while solstice means the standing still of the sun. Please, I want us to pay attention to that. Sol means the sun, and solstice means the standing still of the sun. And it's either of the two times in the year at which the sun reaches its highest or lowest point in the sky at midday. You know, sometimes that period we experience what they call extreme temperature. You know, the sun is at its best in those periods, and I think in that period we can say we have what? Summer. While in winter, which we have our own here in Nigeria, like Harmattan season, you know, at night we experience cold and morning, while during the afternoon we always experience sunlight. All right, thank you very much for watching, and I'm sure you really enjoyed this video. I'll see you in the next lesson. That will be all on revolution of the earth. Thank you, and have a blessed time.